Welcome to a lesson on dividing rational functions, where, given two rational functions f of x and g of x, we need to find the simplified form of the quotient f over g of x and its domain. To divide f over g and find the expression of the quotient function, we divide two rational expressions, the expression for f of x over the expression for g of x. The expression for f of x is 3x squared plus 10x minus 25 over 3x squared plus 11x minus 20, and we need to divide it by g of x, which is 3x squared plus 7x minus 20 over x squared plus 5x plus 4. To divide rational expressions, we multiply by the reciprocal of the second one. So the quotient is actually a product, f of x times the reciprocal of g of x. The reciprocal of a fraction is another fraction that has numerator the denominator of the original fraction and denominator the numerator of the original fraction. Now we have to remember how to multiply rational expressions. We factor the numerators and the denominators, and we simplify common factors. We factor the numerator of f of x with the AC method. AC is negative 75. The two numbers are plus 15 and negative 5. The factorization is 3x minus 5 times x plus 5. We factor the denominator of f of x with the AC method. AC is negative 60. Our two numbers are plus 15 and minus 4. The factorization is 3x minus 4 times x plus 5. We factor the denominator of g of x with the AC method. AC is 4. The two numbers are plus 4 and plus 1. X plus 4, x plus 1. And the denominator also with the AC method. AC is negative 60 and the numbers are plus 12 and minus 5. The factorization is 3x minus 5, x plus 4. We cross off common factors in the numerator and the denominator of the product f of x times the reciprocal of g of x. 3x minus 5 is in common in the numerator and the denominator. X plus 5 is in common, and so is x plus 4. The simplified form of the quotient f over g of x is x plus 1 over 3x minus 4. Now, to find the domain of the quotient function, we have to find all expressions that were ever in the denominator and find the zeros of the factors of those expressions. Now, the expressions in the denominator were the denominator of f of x, the denominator of g of x, and when we flipped g of x, the numerator of g of x. So, again, the denominator, the numerator, and the denominator ended up at some point in the denominator of our quotient as we were performing our math operations. So the factored form of these expressions are 3x minus 4x plus 5, x plus 4x plus 1, and 3x minus 5x plus 4. And the zeros of those factors are 4/3, -5, -4, -1, 5/3, and -4. So the domain is going to be all real numbers except for those zeros. So the domain of the quotient function f over g is all values of x such that x cannot equal to 4/3, -5, -4, -1, 5/3. I don't need to write the -4 again because I already have it.